In this problem, we're given a wavelength and we have to find what is the initial energy level from which the photon dropped from. So there is a starting energy level and it dropped down to the ground state where NF equals 1, and this means this wavelength is part of the UV series, the lemon series. How are we going to solve this? Well, there are a few ways, but we'll look at the way that uses two formulas. So we know that energy, the change in energy between energy levels is going to be given by this formula. This formula. And then, but we don't have energy here. However, because we're given a wavelength, we can use wavelengths to find the energy of that wavelength. So energy is equal to hv, which is also equal to hc divided by wavelength. So we will find the energy here. We know h is 6.626 times 10 to the negative 34, and c is the speed of light, aka the speed of waves, which is 2.998 times 10 to 8 meters per second. And because these are all meters per second, that means our wavelength also has to be in meters instead of nanometers. So we're going to convert this. So times 10 to the negative 9 meters. And this is because you need 9 nanometers to get you 1 meter. So that will get you that. And in short, the energy is going to be around 1.64 times 10 to the negative 18 joules. However, the thing is, because we're going from a high to a low energy level, where a photon is being emitted, that means it is exothermic. And exothermic means this energy should be negative. So here we did it right. However, when we put it in this important formula, we have to take into account that this energy is now going to be negative. It's exothermic because it's going from a high to low energy level where a photon, light, aka energy, is being emitted. So it's exothermic. This part is super important. Always remember this part where applicable, otherwise you'll lose marks. Very sad. All right, so we're gonna put in our algebra here. Our energy, as we have it, is negative 1.64 times 10 to the negative 18 joules. Our R value, and since we're isolating for this, I'll just put my R value beneath here, which is gonna be 2.179 times 10 to the negative 18 joules. That's R. And then for Z squared, this is a hydrogen-like atom, and we're just going to say it's hydrogen, so its proton is 1, so 1 squared 1 is just going to be 1. And then we have our final is 1 squared, so that's just going to be 1 minus our unknown. Okay. So that is going to give us, this has to be negative because it's negative R. So this part is going to end up being positive around 0.75. Here it's going to be 1. Okay. Now let's move things around. We can make this positive by putting it to the left-hand side. And then we can move this to be with 1. So since this side is a positive, we're going to turn it into a negative when we move it to the right. So this will give us 1 divided by 0.25 is going to give us 4, and then if you square root of this, your n initial will be 2.